Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott. And if any of you out there want to speak with us or have one of your math questions answered, and you live here in Bakersfield, give us a call, 636-4357. If you're in San Luis Obispo, the number's toll free, 866-636-6284. You can even email us at dothemath@kern.org. You can watch online, dothemathonline.net, and we are all over social media, Facebook, Instagram, Twitter, YouTube. There are so many ways to get a hold of us. Give us a call.
All right, so we do have phone tutors available until 5:30. If you phone in, and as Scott said, if you would like to see your problem worked out on TV, simply let us know that. You'll automatically be going to the Kern County Fair if you do that. If you're calling from San Luis Obispo County and we do one of your math problems, you'll automatically get free ice cream, courtesy of Doc Bernstein's Ice Cream Lab. So, Scott, officially welcome to Do the Math.
Thank you.
Nice
Glad
to have
be
you
here.
on board. And
Yep.
why don't you let everybody know where you are working right now? So where do you teach at?
So I teach at Bakersfield High School. I've been there
Okay.
for 18 years, and I'm just kind of one of those crazy math nerd guys and seem to enjoy the heck out of this stuff.
Good.
So thought I'd join you.
We're glad to have you.
Thank you.
We have a special guest coming on in just a few moments. We'll be going live out to the ROC in a little bit to visit with our friends from Kern Schools Federal Credit Union. But before we do all of that, let's first take a look at today's Math in the News. So, famous sculptures that you have either seen personally or online or in movies, shows, things like that. When you think of sculptures,
people, right? Almost always people. I think of sculpture, maybe even the bust of a famous president or something like that.
right? Lincoln Memorial.
There you go. Right.
David.
Right.
What was that? Rodin, the thinker.
Right. That's a good one too. I
right.
think, therefore I am. Right.
So a lot of famous sculptures, and I found some, and these are rather unusual. So let's go ahead and
Very.
take a look at the screen right
I
here.
have to agree with you.
As you can see, they're graphite. Now, this artist creates small sculptures. You need a microscope in order to see the details on these. They're carved from graphite rods. There are very few masters of this art because graphite is fragile and the process is time consuming. Many of the projects take days to complete, are so tiny, they're not measured in millimeters, but microns.
Wow.
Now that's what struck me, all right, is because most of the students are probably going, yeah, those are pretty cool. I recognize some of these landmarks and famous buildings. But think about, I mean, the next time you're working in math class or any class and you've got your pencil out, just take a look at that. You know,
the
how
end
much
of
of it
it.
is actually sharpened.
Right.
Right, the end of it, and how you could actually get something like that with that kind of detail
Yeah.
on the tip of that.
Amazingly steady hand. You
Right.
couldn't mess up.
I mean,
because
the
yeah.
tools that you would need
Right.
to use something like that, to
Right.
make something like that, to produce something like that. But then I was like, all right, a lot of students will know millimeters, okay, and they know meters and things like that.
Right.
But microns, I mean, how often do we work with microns? So I
Right.
figured, let's make that our math today.
Okay.
So here we go. How big is a micron? And there's the symbol for a micron. So when students see that, they'll know what that is.
How do you think you say that?
You can, ooh. So you can put 1,000 microns in 1 millimeter.
Wow.
So if you're measuring and you have 1 millimeter, you can fit 1,000 microns inside the 1 millimeter.
So 1,000 millimeters in 1 meter and 1,000 microns in 1 millimeter.
And you can see that a micron,
Wow.
household dust bacteria. Okay? So the bigger things, okay, the hair, right?
Yeah.
When you pluck out a hair,
Right.
when you take a look at that under a microscope, that's 100 microns
Wow.
in size.
Right.
Okay, that's 100 microns. And this guy is dealing in not hundreds of microns,
Right.
microns.
But in single microns.
Right.
Wow.
Spores, dust mites, viruses, these things like that. So I just thought it was interesting, a different unit of measurement
Right.
that a lot of students aren't particularly used to all the time. And that is today's Math in the News. Microns and how small they are. Simply amazing. Do you think you could make something like that?
No.
No? I don't think I could either. You know what? That'd be pretty difficult to make something like that. Now, Riley, you are in here visiting today, and why don't you let everybody know where you go to school and what grade you're in?
I go to Stockdale Elementary School, and I'm in 4th grade.
How's 4th grade?
Pretty fun.
Pretty fun? Well, that's good. Do you like the longer day? It's only 30 minutes more,
Yeah, only 30 minutes.
right? Guess what? When you go to 7th grade, what's going to happen?
Much longer.
It's gonna
Much,
get
much
There
longer.
you go. When you go to high school, what's going to happen?
Longer.
There you go, longer even. If you happen to go to college, what do you think is going to happen?
Oh, I'm going to college.
Oh, okay. Well, good. What do you think is going to happen as far as your time?
Longer. The school day is going to be longer.
It could be shorter,
Guess
but you're going
what?
to be
It's a
putting a
lot
lot of
shorter.
time in.
It is.
Because the number of classes you have may
Sweet.
not be a lot, but you'll be spending a lot of time on those classes.
Right.
But you'll be having a lot of fun too.
Yeah.
But you're having fun in 4th grade, right? What is the best thing, because you've been in school for a couple of weeks now, the best thing about 4th grade? And it doesn't have to be math, I know it probably is, but it could be something else.
Always being on the Acers.
Oh, you're always on the Acer, so you guys have laptops that you guys can use in your classroom all the time, right?
Yes.
So that is pretty cool that you guys are able to do that. Well, I don't have an Acer for you to work on right now, but we're going to make you work. Are you ready?
Okay.
Because I see you have the uniform on already, so we're going to put you to work. Why don't you head on over to the board with Scott?
Okay.
All right. Here's one of the problems from your math book, your homework. So
Okay.
let's go ahead and write this number up on the board.
Okay.
And why don't you start over on the left? So that way, if we need to, we can put some estimates next to these things.
All right.
253,495. 495.
Well done.
And now we will subtract. So if you want to listen to the number first so you'll know where you're going to be writing these things, 48,617. So 48,617. Now in your book, it simply says estimate.
Okay.
So explain to us how you're going to do this.
You're going to go to the highest digit, and then you're going to look next door. If it's bigger, if it's 5 or more, you're going to add 1 more to the 2 and make it a 3.
Okay,
Good.
so go ahead and
Can you do that for
keep
the top
going.
number then? Where'd all the zeros come from?
You get rid of everything else.
Everything else
after.
becomes zeros. Gotcha. All right. Well done. I like it. What about the next one down?
It's a 4, and then the 8's next to it. It's bigger than 5, so you got to add 1 more to the 4.
Gotcha. So you're always looking at the very first number that you see.
Yes.
Okay.
For now.
Well done. So which one do we want to do first? How about the one with all the zeros? All right. Let's do it. Take a look back over here at your original problem. Look way over there. What'd you see? What kind of a problem is this one?
Subtraction.
Gotcha. What about that one?
Addition, because
Yeah.
you need. Oh, yeah. Subtraction.
Subtraction. There
Yep.
you go. And get out your eraser there. We'll just do this. Whoop, whoop. That's pretty
There
close.
we go. That's pretty close.
Good. Okay, now take a look. Ready? Remember we had some subtraction, right? Okay, and tell me a little bit about subtraction. If you were going to do 5 minus 7, right? Can you do 5 minus 7?
No.
What would you have to do?
You would have to regroup.
Yeah, you have to regroup. So let's look back over here first. Ready? Can you do 0 minus 0?
Yes.
Yeah. Can you do 0 minus 5?
Yeah.
Uh-oh. Try again.
Oh,
Can you do
nope.
0 minus... Ah, nope. So let's try again. Well, I'm going to go ahead and erase this part for you right here. Okay? And let's have you try that last part again. There you go. I like what you did there. Now we're good. Go for it. Good. Nice job. Well done. I like it how you fixed that one. Okay, so what do you think? Why in the world do you do this in the first place? I mean, it's a lot easier with a whole bunch of zeros, but why are you doing it?
Because you just can't do it. So
We want to be able to estimate to like see what it's close to, right?
Yeah.
Okay. Well, are you up for this big one right here? Can you do the whole thing? Let's do it. You're already an expert in regrouping. Well done. There you go. Good. So 15 minus 7, right?
Yep. It is
It's coming.
8.
Well done. Yep, you got it. And then we got a 7. Uh-oh. More regrouping just for you.
Yep.
I like how you write the whole new number there. That's a good idea. Got another 8. I got to get in here. I'm going to put the comma in there.
Okay.
All right. How about 2 minus 8?
Nope.
Nope. More regrouping. Seems to be your favorite thing today.
Apparently.
All right.
really, but-
Now you got 12. Good. Good.
And then the 2.
Good. Nice job. Now let's compare these two numbers. Look at them real quick. Can you tell me what this number is right here?
250,000.
Good. How about this number over here?
204,878.
And if this one at the end of your problem ended up being 749,000, what would that tell you?
My estimate is wrong.
Oh, your estimate's wrong? Or maybe even you made a mistake over here, right? Something's wrong, and it gives you a hint. Maybe I should go back and take a look at what's going on. But these ones, they're both in the 200,000s, okay? Not super close, but they're close enough for us to know that they're probably pretty good. Well done. Nice job. I like that problem.
All right, good work right there, Riley. We'll give you a break right now. Hey, you know what? On Wednesdays, we go out to local businesses to find out exactly how they apply math in what they do. Right now, we're going to go visit Devin at the ROC with our friends from Kern Schools Federal Credit Union.
Hey, thanks a lot, Mike and Scott. It's great to be back here. I hope you guys had a great summer. We're back live out in the field for Do the Math. And today we're here at the Kern High School District's Regional Occupation Center, The Rock. I hope they call it The Rock because it would be a terrible tragedy if they had something like that and didn't utilize it. So we're going to be here all day today exploring what exactly goes on here. Right now, we're right in the main foyer, the main entrance, with Brian Miller. And Brian Miller is the Career Technical Education Supervisor. Brian, thanks for joining us on the show. Great title.
Thank you, Devin. Yeah, thanks for being here at The Rock. So
I've got a daughter. She's 6 years old. Every now and then somebody's going to ask her, what do you want to be when you grow up? And she hates the question because she only knows like 9 things that she could possibly do. Here at the Regional Occupation Center, kids that enter in here, they at least have an opportunity to look at a lot of different opportunities they could have for careers.
yeah, currently we have 27 different career training programs here, which is a great opportunity. It's open to juniors and seniors in the Kern High School District. They come here for a year-long program for 3 hours a day where they get some top-notch training, and it's just a great opportunity for them to explore an area that they're interested in.
Regardless of whether or not they're areas of interest, it's opportunities to really see how the world operates beyond what's familiar to them. Not only an opportunity to find out what they may want to pursue, but sometimes it's just as valuable to figure out what paths you may want to avoid as well. Try something out and maybe it's not working out.
Yeah, exactly. We let all the students know that at the beginning of the year because many of them are here because they know that's what they want to do. But a lot of students will get in there and, part of the program is an internship or that community classroom piece and a lot of hands-on opportunities. And a lot of them will figure out that's not what I want to do. It's just as valuable of an experience for them.
Now, here on the main entrance, you've got some displays that kind of highlight some of the programs. I wonder if you'd take a walk with me and we'll kind of take a look at some of these. Well, I mean, this is great for the guys behind the camera here, right up our alley. So video production, I mean, a big push for this in media-rich 21st century environment.
Right, and this is actually a brand new program for us that just started this year. So we're We're super excited to get that off the ground. Students will get, experience in all aspects of the film industry, and also some hands-on experience in there as well. So we've got a wide variety of programs. Pretty much every single industry sector is covered here. We've got a lot of the tech-related ones, like our mobile app development education program here, MADE, he calls it. We've got a video game design program, a Cisco networking program, just some of the tech-related ones. We've also got a wide variety of healthcare programs, 5 different ones from medical assisting, nursing assistant, dental assistant, among some other ones as well.
Especially with things like entrepreneurship and mobile apps, these are the kinds of things where, you don't need to wait for somebody to hire you in order to be successful and make a living. This is something that you could start from the ground up no matter how old you are. So, thinking about that component, not just of the creation of the skill itself, but also how to manage yourself as if you were your own business.
Right, exactly. And really those career readiness skills are something that's embedded in every single program here, and that's really where it gives kids a head start on the next step after they leave high school. Actually, most of our students do go on to post-secondary education, and that's something that we strongly encourage, but they start the path here at the ROC and they get those foundational skills and also the guidance that'll get them to that next step.
Perusing a little bit further down as we navigate through here the hallways at the Regional Occupational Center here on Mount Vernon Avenue in Bakersfield, you get the sense as you enter some of these spaces that these aren't necessarily classrooms. These feel like professional settings.
Yeah, and that's really this school is really, the feel of it here is that it is like a place of work. We don't have any bells here, which is probably the first thing that students notice when they come to our campus. And students are treated like professionals, and we treat them like they're our employees here. We have high expectations for them, but we find that throughout the year they really rise to the expectations that we set.
Right along with that is making sure that you build a professional environment that seems like its own community. And one of the things we'll take a look at here, of course, is the Current Schools branch. Tell us a little bit about that relationship.
Yeah, it is really the relationship that we have with Current Schools is really that model partnership with industry, and our industry partnerships are critical for all of our programs here. The Current Schools provides tremendous support as far as just giving us guidance with our curriculum, but even more so with the hands-on real-world opportunities that they provide our students. So every single one of the students in our banking program gets an opportunity for an internship, and the majority of those are in a Current Schools Federal Credit Union branch. But we also have, which you'll see in a minute, our on-campus branch here where students are working and running that branch every single day.
We can go ahead and take a peek as we look in there. Coming up later in the show, we're going to dive a little deeper into the branch, but there's no reason we can't come in and say hello. How's everybody doing today?
Hey, good. How are you?
So this is an actual functioning branch here at the Regional Occupation Center. This is no playhouse. This is where you can come in and actually navigate through the banking system as a member of the financial community. And so a little bit later on in the program, we're going to meet with everybody here at the Current Schools branch here at the Regional Occupation Center, talk a little bit about how the skills that you're learning about actually apply to things like savings or checking accounts, and how the decisions you make based on the calculations that you have handy influence not just what ends up with your accounts, but the work that everybody here at school managed to do. So we'll check back in a little bit later on in the program, but for now, we're going to throw it back to the studio. We understand a lot of people calling in with problems, but that means that there's a lot of people calling in that are going to get some solutions. So Mike, we're going to throw it right back out to you in the studio and be back a little bit later on.
All right, thanks for that, Devin, out there. You can always bring some money back. Just make sure you leave your name with the credit union out there. Right now, we're going to go to the phones. Our first phone caller of the afternoon, Lupe. How are you today? Hello, Lupe. Are you there, Lupe? I think we had Lupe, a 5th grade caller from Williams. Are you there, Lupe? Well, you know what? If we get Lupe back in a moment, we are going to make you get back to work again. Okay. Are you ready?
Let's go, Riley.
Head back to the board. What I'd like to do is give you one of the numbers that you were already working with. All right? 48,617.
So it's 48,000.
617.
670. Good.
Now, after the 7, I'd like you to put a decimal point. Now, you're going to have to make it a little larger.
Well done.
There you go. Now, select a number between 1 and 8.
7.
Go ahead and write it up there. Write another between 1 and 8.
Can it be 8?
It can be.
Sure.
Now, Scott's going to talk to you briefly about the place values after that decimal point, and then you're going to round it
Okay.
to the nearest tenth.
Okay.
Okay,
Ooh,
so
fun.
take it away.
Are you ready?
Yes.
So tell me a little bit about these place values here. What place value is the 6 in?
Hundreds.
Good. And what about the 1?
Tens.
Tens. And then we have over here the 7?
Ones.
Ones. Gotcha. And the way we signify a decimal in math is with the word and. So when you see that word and, that's when you write the decimal.
Okay.
And then after that one, over here, everything on this side over here ends with a THS. And you have to watch out when you say that, because if you say it too fast, you end up spitting on the person next to you. You kind of watch out for that. So over here, the very first place that you'll go to is just like this place you had here, right? The 10,
Okay.
but guess what's on the end?
Decimal point?
THS, right? Right, THS, right at the bottom there. THS. So ready? Don't spit on me. Let's see if you can say it though. Tenths.
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 Seven.
There you go. Gotcha. And the next place over, right? Just like the next place over to the left.
Yeah.
This is tens. This is hundreds, right? This is tenths. This is, let's see if I can do it quickly, hundred. What goes in the end?
TH.
THS. You got it. So everything over there has a THS on there, right? And all the people from Tehachapi High School are really excited right now because there's a THS over there. So here we go. We have tenths and hundredths. And Mike, we're rounding to the nearest tenth. Is that correct?
Correct.
Gotcha. Okay, so let's identify the one that is in the tenths place. Which digit is in the tenths
The
place?
7.
The 7. And which one's going to help you round?
The hundred.
Gotcha. Here's what I like to do in my classroom. We say, you know what, that's the one we're going to round, and you told me that the hundreds is going to help you round it, right? All right, so what do you think? What's going to happen to that 7? Is it going to stay the same or go up?
I think it's gonna go up.
Awesome. What about all these numbers over here?
Something's gonna happen to them.
Something's going to happen to them too?
Yeah.
Well, you know what? Today we are just hanging out with these
Okay.
decimals. So let's keep everything the same.
Okay.
Go ahead and write all this stuff right before the decimal, all the same over there.
Okay.
So 48,000. 617. And what do you write? Get that dot on there. You can do it. There you go. Good. And now you told me what's going to happen to the 7?
The 7's going to go up.
Good. What's it going to go up to? 17? No. What's it going to go up to?
8.
8. Let's make it an 8. And then what happens to the 8?
Gets to a 7.
This one right here?
Yes.
Well, here's the great part about this method. The reason that I like to do this, we identified the tenths place, right? We circled the 8 because it was going to help. And because I circled it, it reminds me that it changes to a 0, just like all those other zeros that you had in your other problem. So after you round, pick that up. There you go. Hold on to it for just a second. After you round, everything else after the place that you rounded becomes a 0.
Okay.
And that helps me remind myself, like, what does it come? Oh yeah, it becomes a 0 because I circled it.
Okay.
So there we are. We rounded to the nearest tenth. Nice job.
There you go. Good work. And we'll have you work some more decimals later on. But right now we're going to go back to the phones. And I do believe we have Lupe available. Hello, Lupe.
Hello.
You're a student at Williams Elementary, correct?
Yes.
All right. As soon as you're ready, let's hear the math problem that you're working on today.
3,502 times 741.
So 3,510,
No, 3,502.
502.
Okay.
Yes.
And what are we multiplying that by?
741.
741. Wow. Lupe, that's a good one. Nice and big. You got a good big one there for us. Now, do you want to do it just like I've written it? Can you see it on your TV? Do you want to do it just like I've written it, or should we break it up into pieces?
I'll do it how you write it.
Just like you wrote it? Okay, so if you can tell me, just like I wrote it, what's the first number we're going to multiply everything by?
1.
1, that's it. All right, so 1 times? What am I going to multiply 1 by?
2.
2, you got it. What's next?
0.
0, good job. And then the next one is 1 times 5. What's 1 times 5?
5.
Yep, you got it. Well done. And the last one, 1 times 3?
3.
3, you got it. Now look at that. This number on top is exactly the same as the number we wrote because all we did was multiply times 1. So I like to multiply times 1. It makes your job a little bit easier. All right, in the next line, can you tell me what place value the 4 is in?
The 10th
The
place.
tens place. That's exactly right. And we have to show that somehow. So we don't have any numbers over here in the ones place. I'm going to go ahead and cross that out for you because we don't have that yet. We have numbers in the tens place, right? That's the 4. So what should we multiply the 4 by?
2.
2. All right. What's 4 times 2?
8.
8. All right. 4 times 0?
0.
Nice job. Next, 4 times 5?
20.
20. Can I write the whole 20 here like this?
No.
No, not so much. Huh? There's no room. There's only one spot there for it. So this 2, it's got to go somewhere else. That didn't work out very well. Good thing I'm working with a pencil like you do in math class, right? Where does that 2 go?
That 2 goes over the 5.
Yeah, you got it. Oh, wait, you know what? We just multiplied times 5, so I'm going to go ahead and put your 2 way over here by the 3. How about that, okay?
Okay.
So, 4 times 5, right? We had that 20. We put the 0 down and carried the 2. And now we have one last number to multiply times 4. So 4 times 3 is what?
12.
12. Lupe, you're doing a wonderful job. Now, what about that 2? It's kind of hanging out up there. What do we do with the 2 and the 12?
12 plus 2.
Yep, you got it. And I'm going to go ahead and write that right over here. It's 14, right? Nice job. Okay, so we have one more to multiply by. And the last one we have to multiply by is at 7, right?
Yes.
Good. So what place value is the 7 in?
The 100th place.
You got it. It's exactly right. So we don't have anything in the ones place. We don't have anything in the tens place. We have to go right to the hundreds place. And here we go. Are you ready? What's 7 times 2?
Yes. 14.
14. Gotcha. You want to put a 14 in here?
No.
Oh, okay. I'm sorry. So we're going to go ahead and get rid of the 1. We put the 4 down. We're going to carry that 1 like we did last time right over top of the 0. So what's 7 times 0?
0.
0. And then what about that 1? What do we do with that?
Plus 1.
That's it. You got it. And 0 plus 1? We actually ended up bringing that 1 down. That was interesting. Next, 7 times 5.
35.
35. Well done. And I'm going to go ahead and beat you to it because I knew you were going to tell me. The 5 goes down. We're going to carry the 3. I don't want to get confused with this 2 here. So we'll put a 3 right there. Okay. And the last one, 7 times 3?
21.
21. And then plus 3 more?
24.
24. Good job. I got to squeeze it way over here. Hopefully you have more room on your paper than I do. Now we have all these numbers, and what's the very last step, Lupe?
To add all the numbers.
You got it, man. Well done. I like it. Here we go. So 2 plus 0 plus 0. What do you got at the bottom?
2.
2. That's right. I'm going to go ahead and change colors on you here. Watch this for our answer. What about the next one? 0 plus 8 plus 0.
8.
8. Good job. Next, 5 plus 4?
9.
9. 3 plus 1?
4.
4. Oh, you're doing a wonderful job. 4 plus 5?
9.
Yep, you got it. 1 plus 4?
5.
5. And then we have the 2. It's way over there. I still have to squish it in. Now, the last thing I need you to do is to tell me, Lupe, where do the commas go in this problem? Because we have so many numbers, we're going to get all confused saying this number unless we put the commas in the right place. You want to put a comma between the 8 and the 2, 9 and the 8? You tell me where to put them.
Put the comma between the 2 and the 5.
Oh, I like that. Right over here? And what else? Any other commas?
Yes.
Where do you want to put that other one?
Between the 6 and the 9.
Ah, yeah, it looks like a 6, but I have bad handwriting. It's actually a 4. So I'm going to go ahead and put it right there for you. Well done. Now here's your last and final thing. Can you tell me what this number is in words? Can you say that number, the final answer?
2,596,982.
You got it. And then again, I have to remind you, this is a 4, because like I said, bad handwriting. This is a 4 right here. So 594,000. Great job, Lupe. I'm impressed. Well done.
There you go, Lupe. Nicely done. And because that was such a wonderful problem, we're going to send you to the Kern County Fair. So hopefully you have an opportunity to attend the fair and have a good time out there. Have you been to the fair?
Yes.
What's the best thing about the fair? Why do you like
rides.
them? You like the rides? What ride do you like best?
I don't know. There's a lot of good ones.
Is there one that you always go on or one you go on first to make sure you get to it?
No?
No? You know what? Have you ever done the one where I think it's the Ferris wheel, but the car is turning while the whole wheel is
No.
well,
Too
try
much
that out
turning.
sometime. After you eat, it's fun. All right. Hey, you know what? We'll be back with more right after this. Today we're at Elk Hill School, and today we're here to Well, we're once again at Elk Hill School, and with me is Jordan. How are you today?
Good.
Good. What do we have up here?
Fractions.
Fractions. Can you go ahead and read them for me?
2, 5.
2 over 5, 2
2 over
fifths, right?
3/7, 1/3, and 2/4.
Good. Do you have any idea what we're going to do with these?
No idea.
What do you think we could do with them?
Subtract them.
Well, we could subtract some, but we'll do something even easier. We'll just put them in order, all right, from least to greatest, all right? So we're going to go with the smallest fraction and end with the largest one, all right? How do you think we should go about this if we want to put them in order?
Do by the bottom ones.
Okay, so we have a 5, a 7, a 3, and a 4. So looking at that, you would think that 1/3 might go first? All right, so why don't you go ahead and write 1/3. Then what?
2/4.
Okay, so you know what we'll do is we'll just put a comma there and go ahead and write 2/4 next. Then what?
2/5.
Okay. And finally,
3/7.
3/7. You know what? Looking at it, it looks like you had a pretty good start on this because it may turn out where this is actually the correct way, but we'll have to take a look at it and see. All right. So let's think about it first of all. All right. 1/3. Okay. Do you know what that would be in a decimal form? It would be about 0.3. 333, right? Keep on going. 1/3, right? 33 and a third out of 100. Okay. 2 out of 4. What would that be? If you have 2 out of 4, you have like a half, right? And how would we do a half? Do you know how to put a half? So it would be 0.5. If you had 50 cents, half of a dollar, okay? 2 out of 5, do you think 2 is at least half of 5?
Yeah.
Okay, because 2 1/2 would be, right? Okay, so that's gonna be less than a half, okay? If we wanted to turn this in, because these we're doing out of fractions, right? And we're turning them into decimals. If we wanted to take the 5 and turn it into a 10, what would we have to do to the 5? 5 times what would be 10?
Times.
Right, 5 times 2,
2.
right? So if we go 5 times 2 to get 10, we're gonna go 2 times that. So it's 2 times that. So 2 times 2, and you get 4, exactly, right? So go ahead and put a 4 up there. So 4 out of 10 is the same as 0.40. Perfect, okay? So then we have 3 out of 7. 3 out of 7, because 3 1/2 would be half. But that's not even half, is it? It's less than that, okay? So taking a look at these, first of all, which one of these decimals is the smallest?
This one?
This one, right? Because 0.3, right? Because you basically have 0.3, 0.5, and 0.4. So 0.3. So that is the first one. All right, so this, out of these 3, forgetting about that one, this one is still going to be first, isn't it? All right, so let's go ahead and write down 1/3 again right there. Now, out of these 2, 0.5 and 0.4, which is smaller? All right, so it's not going to be this one again, is it? It's going to be that one. So put 2/5 next. All right, then what?
Then
Which was
2/4.
2/4. And then what's last?
3 7.
3 sevens. But we didn't check that yet to see if it was correct. So put 3 sevens first, right? And now we'll check it because we know that these three are in correct order, okay? So all we have to do is see if this is bigger or smaller than that, okay? So we have a 4 and a 7. So what we're going to do is when we compare fractions, we'll make the same denominator, all right? We're going to make them out of 28, okay? So 4 times 7 is 28. So we're going to go 7 times that. So you know what 7 times 2 is, or 2 times 7?
14.
There you go. So put a 14 up there. And this one, to go from 7 to 28, we multiply by 4.
4.
So now we're going to go 4 times 3.
12.
There you go. So put a 12 up there. So out of these two, 14 and 12, which is larger?
14.
The 14 is, which is this one, right? So let's go ahead and write these first two down again, because we know those are in correct order. Good. Now, out of these two, which one is actually smaller? That one, which was 3 sevenths, right? And what is the final one now?
2 fourths.
2 fourths. See, and what we can do is we can look at this now and go, all right, the numbers didn't go exactly in order as far as the bottom ones, like you were saying at the beginning, but we were pretty close. But 1/3's not even a half. 2/5, not even a half. 3 sevenths, not even a half, but we know 2 fourths is a half. So we know that by looking at it, that is going to be the largest one, and we just proved it. Jordan, nice work. And once again, a special thanks to all of the staff and students at Elk Hill School. We had a wonderful time going out there to visit with everybody. Hey, if you'd like Do the Math to come out to your school, simply give us a call. The phone numbers are at the bottom of your screen periodically throughout the program. Just speak to one of the phone tutors. They'll get us the information, and we'll see if we can make something work out there together. We also are going to head back out right now with Devin and our friends from Kern Schools Federal Credit Union. They're at the ROC.
Hey, thanks a lot. We're back here at the Kern Schools Federal Credit Union branch at the Regional Occupation Center. We've been exploring the facility here and learning a little bit about how a lot of what the kids do in this facility really mirrors what they'll do in the real world. Joined right now by Kiana Nelson. Kiana, thank you for joining us on the show today.
Thank you for having me.
So, this is a fully functional branch, very similar to what students at any of the other Kern Schools branches. Tell us a little bit about some of the similarities and differences.
Major difference here at Kern Schools is that it's the student branch, that it's completely run by our high school students. They can be a junior, senior to be in this program. They do mostly all the same actions that we do at a fully functional branch, but since we're on a smaller level, they'll just do deposits, withdrawals, payments, but we give them the same great service that we would at a bigger branch.
So maybe they're not taking out home loans or anything like that, but a lot of the interactions that you would normally do within an actual branch are there for the students.
Correct, yes. The students can do all of our transactions that you would do at most of our big branches, deposits, withdrawals, transfer payments, things like that.
In order for students to be a part of the program here, are there any requirements as far as participation, classes, anything like that?
Yes, here at ROC, they are part of what is called the Banking and Finance program. So they are part of that program, and then they can get an internship here in the credit union. So we do hire juniors and seniors as high school students to work in here, but they interview, and then that's how we base our decision on who we pick.
That's a big part of it too. The interview process is something that if you're not familiar with when you do start applying for programs and positions can be very intimidating. So having that experience of being able to sit down and really explain your benefits and selling yourself as somebody who can contribute in a professional environment, it's really valuable. I mean, you're never too young for that.
Mm-hmm, exactly. That's what we want to start off in that interview skills starting from the beginning so they are ready for the work field.
We wanted to take an opportunity and really explore the kind of math that takes place here, and it may be familiar to a lot of you at home as well. So let's go ahead and take a look behind the door here. I would not recommend going behind the door of any bank branch without explicit permission. A lot of alarms tend to go off, and banks tend to get very nervous when you get near things like vaults or safes without being asked first. But we got special permission today. I hope we have special permission today. You do. Okay, thank you very much. So join here with Angelica and Paola to talk a little bit about the kind of math that you might start to interact with either behind the counter here or on the other side. So we were talking a little bit about things like savings and something very significant in types of accounts, interest rates. Could you go ahead and just kind of tell us a little bit about what an interest rate is?
Yeah, so basically it's a percentage of the loan that a member is being charged. So let's say that you want to take out a loan for a car or something that you want to purchase for $1,000 and the interest rate is 10%. So 10% of your loan is what the member is going to be charged for.
So in addition to the $1,000 that you'd have to pay back, you're basically paying back a fee to the bank for the right to borrow that money that you would pay progressively over that term. So, you know, it may not sound like a big deal, but if you have, let's say, a $1,000 loan at 8% or a $1,000 loan at 10%, how could we figure out what the difference between those two would be?
I mean, we can go ahead and do the math on here.
That's what we do here. Wonderful.
All right, so let's say, you're taking out a loan for $1,000, and like we said, the interest rate is going to be 10%, so we're going to multiply that by 0.10, and then we have all zeros here, so we're going to zero that all out, and then we're going to bring down a zero here. Again, now we have the 3 zeros right up here, and then 1 times 1 is 1, and then we're going to move our decimal over here. So for 1 year of borrowing a loan of $1,000, you're going to be paying $100 in interest.
What's really interesting about the way that you multiplied that is that when you talked about 10%, is that you actually wrote that out as a decimal point of the 1 0. And sometimes people will write that value as just a 0.1, but when you put that in with the standard multiplication algorithm, it comes out to the same thing. And I know sometimes that decimal really throws people off, but I generally is I'll write that as a percent, we mean out of 100. And when you multiply the decimal representation of the percentage as a fraction, actually it's easier to multiply. So you have 1,000 times 10, which is 10 thousandths, times 1 and 100. And so you can get rid of those zeros as well, and you'll still get 100 divided by 1, or $100. So a 10% interest rate means you're going to be paying $100 extra to the bank. And you can pretty much calculate, if you tried to do that with an 8% loan, that would end up being $80 back to the bank. So the difference there is $20 over the term of that loan.
Yeah, so you definitely want to go somewhere where you have an interest rate that is lower. That way you save yourself some money in the long run.
It doesn't sound like a big deal, 2%. But the bigger the loan, the longer the term, it has a big impact. Paola, thank you so much for working that through with us. We're going to come back a little bit later on and go a little bit more in depth about where this takes students that take part in this program. But for now, back to the studio. Mike, take it away.
All right, thanks for that, Devin. Hey, do remember we have phone tutors available until 5:30 on most Tuesdays and Wednesdays throughout the regular school year. Right now, we're going to go back to the phones. Another student from Williams, and this is Hannah. Hello, Hannah. How are you?
Good.
As soon as you're ready, let's hear the math problem that you're working on.
Okay. It was a moving company hired 578 clay pots to a florist shop, and the florist will pay the moving company $200 fee. And I found the answer for it. It was 4 plus 2 equals 6, and the number of pots delivered safely were 572.
Gotcha. Okay, so we have 578 pots, right? And
Yeah.
tell me a little bit about this fee. We have a $200 fee, right? They're just going to
Yeah.
pay them a flat $200, or they're going to pay them per pot?
Excuse me? What?
Are they going to pay the moving company per pot that they move, or just flat $200?
$100 for each pot that is delivered safely.
Whoa, that's a lot of money for pots. All right, are you sure it's 100? Check that decimal place. 100 or $1 per pot?
$1 per pot.
Oh, gotcha. Okay, so they're going to pay $200 no matter what, and then $1 per pot that makes it safely. So out of these 578, I heard you say something about, I don't know, some pots got lost or broken or something like that. How many of them actually made it to where they needed to go?
Yeah. If 2 of the pots are lost.
Oh, okay. So if 2 of them are lost, what do you want to do with that 2?
You want to add it because because 4 plus 2 equals 6.
Gotcha. Well, think about this one. Ready? I got 5 right here, right? If I lose 2, oh, they're gone. What do I got left?
3.
Right. So what did I do? I subtracted, right? So let's go ahead and do that on this one. We have 2 pots that are lost that you tell me about there. So how many pots, Hannah, can you tell me that actually made it to where they were supposed to go? What's 8 minus 2?
572.
Almost. 8 minus 2?
576.
Good job. Okay, so 576. And you said it was $1 a pot. That makes it really easy because we can just go like this. $, $576, right? And then you also told me at the beginning that there was a $200 fee from the beginning, so we can't get out of that. So we better add that to this as well. Can you help me do some addition here, please? What's 6 plus 0? Hannah, you with me there? What's 6 plus 0?
6 plus 0 is 6.
Good. What about 7 plus 0? 7 plus 0? You got it. It's a 7. I'm going to ask you a trick question here. What's 5 plus 2? Ready? You can do it. 5 plus 2.
7.
There you go. So we got 2 7s and a 6 at the end. And so this is how much money we're going to pay to get those pots moved. Now there's one last part of this problem that you told me about, and it said, what happens if the pots get broken?
If the pots get broken, they have to pay the company $24.
Oh, they got to pay some money, right? So they got to pay them back. They're not going to pay for that. So far we have this amount, right? Can you tell me how many pots got broken?
4.
4 pots got broken. And how much do they have to charge for each pot that breaks?
$4.
Good job. So we got $4 here. So what do you want to do? Add, subtract, multiply, or divide? We got 4 pots, and each of them is $4. We can even do this, right? Out of these 4, we can see 4 of them. We got $4, and $4, and 4, and 4. So all together, how much are we not going to pay for? Can you add all those together? 4 plus 4 plus 4 plus 4?
16.
You got it. Well done. And so if you look back over here, what do you think I was looking for here? We have 4 and 4. What do you think would be a little bit faster than adding them up? Multiply, divide, add, subtract. What do you think? I'm going to give you a little hint here. Ready? There's your $16. So the deal is, right, you can't pay for pots that are broken. Nobody wants broken pots when you get there. So at the very, very end, we were supposed to pay $776, right? But we can't pay for the pots. So now what do you want to do with these two numbers? We got 776 and we got 16, right? We are not going to pay for them. So what does that mean? Add, subtract, multiply, or divide?
We want to subtract how many pots were.
Great idea. Let's do that. I'll put a dollar sign down here so we don't forget. What's 6 minus 6?
6 minus 6.
What's 6 minus 6? You can do it.
0.
There you go. We're going to go in green now because we're talking about money. 7 minus 1?
7 minus 1 is 6.
Good. And then we don't have anything left for this 7. So at the very end of the problem, if you can see on your screen, how much are you going to pay this moving company to move all those pots?
760.
Nice job. Well done. I like it.
Nicely done, Hannah. Congratulations on that. And you're also going to the Kern County Fair, courtesy of our friends out there, so we hope you have an enjoyable time out there if you're able to make it. Hey, we do have phone tutors available until 5:30, and we had somebody email a question, and we got back to them, but we're going to put it on air right now, but we're going to make you do it.
Okay.
Okay, sound good?
Oh, Riley's ready.
It has some decimals in it, and you've gotten used to decimals a little bit today. So we're going to work with this, all right? So we'll wait for Scott to get the board erased.
Nope, not going to do it that way. You want to grab your pen? We'll see if we can get this area all cleaned off here for you. You want to start erasing? It's not doing it for me today. Okay.
Here, you know what? You have your...
You want to go back on that one?
Yeah, hold on there. Let me.
All
there
right.
we go.
Hey, look at that.
All right,
Back
here we
at
go.
it. Here we go.
And indeed, hooray. All right, so you've got 3 minutes to solve this problem.
We can do it.
All right?
Okay.
Carl is building a table. The boards are 4.25 inches wide.
Okay.
Here we go.
So every board is 4.25 inches. The table needs to be at least 36 inches. How many boards will she need?
Gotcha. Any kind
And
of
you
estimate?
have
Round 8.
a little over 2 minutes right
We can
now.
do this. We can do this. What do you think about an estimate? What do you think it might be close to? And we'll kind of try that.
8.
8. How come 8? Well, let's see. Let's see where we're going to end up. What's 4 times 8?
4 times 8
Yeah.
is 32.
Gotcha. Okay, so if we were going to multiply this number times 8, right? Then we would get approximately, maybe not quite, but about 32. So that's pretty
Yeah.
darn close. Gotcha. What do you think? Do you think we can actually multiply this out and see what the real answer is?
Maybe.
Maybe. All right. So at least we're pretty close. And if we're
Yeah.
not quite high enough, now it says that we want to be at least, right? At least 36.
Yeah.
So if we're not over 36, then we're going to be in trouble. We can go one more. But we'll see kind of how this goes. All right, where do you want to put that 8?
The 8. Let's see. Under the 4.
Underneath it. Let's go ahead and do that. Why don't you put it underneath the 5, and then we can be able to multiply. There you go. And a big line. Nice. Now don't worry about the decimal for right now. We'll just go
Okay.
ahead and multiply that out.
Okay.
Go ahead. You want to multiply it?
Sure. 8 times 5 is 40.
40. Good job. And the 4 goes way up. Well done. I like how you put the plus sign in there. Reminds you.
8 times 2 is 16.
Good. I'm glad you're
plus
talking it out.
4.
And then we got 4 more. And that gives you a 20. Good job.
And
And 8 times 4?
4 is 32.
Plus 2
2
more?
is 34.
34. Gotcha. Now, how many decimal places did you have in this problem here?
1.
Tell me about 4.25. How many decimal places does that number have? Remember we talked about the first place is what?
Is 2, 2, 5.
The tenths. Remember the tenths place? And the next one is
The 100.
the hundredths. So we have 1, 2 decimal places. So that what that means is we need 2 decimal places here in the answer.
Okay.
Can you go over 2 places and put your decimal in there?
Maybe right here.
Yep, right there.
Right here?
Yep, right there. You got it. That decimal really will show up.
Circle.
So the answer right here, as far as we have, right, is 34.
And I'll
Now
give
we're
you
back
30
to the question.
seconds to finalize this
We're
problem.
back to the
Oh,
question.
okay.
Is that enough? Is it 36?
It's
It's about, but not quite, right?
Wait.
So if we want, do we want to get bigger or smaller to get to 36?
Bigger.
Bigger. So let's make this 8 go up 1.
9.
9. There you go.
Okay.
So your estimate was a good one. We tested it out. It didn't quite work. But we're going to have at least 9 to get to 36, right? Nice job. 9 boards. Well done. I like it.
There
I'm
you go,
impressed.
because that will put you over the 36, because it'll say 34 plus the 4 is 38. The extra is extra.
Extra is extra.
Nice work right there. Hey, you know what? Final time this afternoon, we'll go back out to Devon at the ROC with our friends from Kern Schools Federal Credit Union.
Hey, thanks a lot, Mike. Back here at the Kern Schools Federal Credit Union branch at the Regional Occupational Center on Mount Vernon Avenue. Wrapping things up here on a Wednesday afternoon with Angelica Alvarado. Angelica, thanks for joining us this afternoon.
Thank you for having me.
So I want to turn back the clock a little bit.
Okay.
The year's 2004. What's going on in this location and with you here in Bakersfield?
2004, I am a senior in high school, and I am the first class opening this branch. So my year was the first year that this branch here, specific branch ROC, was opened. I was a student. I was nervous, I was scared, but I was excited, and I am here now as an employee.
So what was that transition like? I mean, what was it from here to the full position with Kern Schools?
It was, I mean, this gave me all the experience that I needed to be where I am now. I learned everything, to everything from a handshake to eye contact, professional dress, professionalism, confidentiality, just different things like that, that at home, because my parents were always at work, I didn't necessarily learn it from them, but this gave me all of that experience. So it was very helpful and very beneficial, I feel.
In terms of coming into the organization, it's helpful because a lot of the same systems that you use here are the exact same things, like the computers, the rules, the procedures that they use at the full branches.
Right.
Yeah, everything that we have here is exactly it's live. We're a live branch, and so everything that our students learn here is everything that they do at one of our regular branches. And so we teach them everything that they need to learn, and so a lot of them start applying for jobs at towards the end of the school year, about May. And if they are hired, then they are ready to go. We don't have to retrain them because they've already had the full school year worth of experience and training. So. It's pretty seamless.
So if somebody is in the high schools right now and they're looking to get involved with the program, what are your recommendations, or what is the process for that?
If anybody is here locally in Bakersfield, all they need to do is be a sophomore in high school or a junior. You can come see your counselors, and they have all of the information. So all they need to do is be enrolled to Regional Occupational Center, and then the banking and finance class is the class that's attached to this particular internship. And so once they're enrolled in the banking and finance classroom, then they will have the opportunity to then apply and interview here with Kern Schools. And then we start training them right before school starts.
Well, Angelica, I wanted to thank you and everybody here at the Occupational Center for their hospitality and bringing us in today and letting us look around, bringing us behind the counter. I know that is a wonderful blessing that you've given us the opportunity to do so, because I know that this is sacred, hallowed ground in the financial community. And to thank you for your continued support with the Do the Math program, as we do with anybody who makes a significant contribution civically with our show. We wanted to offer you, as a token of our appreciation, our Do the Math tile, as is tradition with the program.
Thank you.
Really nice here. Check in through us throughout the season as we visit more and more businesses in the Bakersfield area, as well as anywhere where math is happening, to see how this applies. What you have going on, things that you're picking up, you use them today and you use them for life, as we've been able to see. Yes. So, Angelica, thank you so much, and everybody here at Kern Schools Federal Credit Union at the Regional Occupation Center. We're going to send it right back out to the studio. Mike, Scott, take it away.
All right, thanks for that. We've got Riley in here, and she thought she was finished working today, but you still have a little bit to do. We do have phone tutors available until 5:30 this afternoon, and you want to go work on the phones and answer questions for a little while?
Sure.
Yeah, there you go. That's what I like to hear. Phone numbers are at the bottom of your screen. Do remember, every time next week, next Tuesday and Wednesday, we do one of your math problems, you will also win yourself a free ticket to the Kern County Fair. But the students that phoned in today are also entered into a drawing to go see the Bakersfield Condor. So reach in there and pull out one of those names, and we'll find out who's going to see the Condors. Who is that?
Hannah.
Hannah. So there you go. Congratulations. I believe that was our last phone caller right there. So you're going to see the Condors. And since you're going to work on the phones a little bit, you did some work today. We're going to let everybody see your new uniform right there. Do the Math shirt. And your mom already said that you could wear that every day for the rest of the year, except for campaign week, right?
Yeah.
All right. There you go. Nice deal.
Not every day. It has to get washed sometimes.
Do that on Saturday and Sunday. All right. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.